Hi, this is Chris at Agrimodis. At the end of our intro video, we had a tale of three tissues slide pop up. I said we're going to save that for a different presentation. So we're going to tackle that today and do a quick deep dive into nitrogen and R&D that we have comparing leaf tissue data to our Agrimodis testing system. So here's the tale of three tissues. And if you saw any of our presentations over the winter, you've probably seen this already. But most of the time, the audience were consultants and agronomists, and I would ask them if you had these three results coming in from three fields at V10, what would you do with the information? Which ones require nitrogen? How much nitrogen would you put on there? And I'd get a mix of responses. But I think most of us have been going by lab ratings of what is okay with nitrogen. What where can we what are different goals and things? There's a lot of different publications about that. Who do you listen to for what that nitrogen percentage needs to be at different growth stages? But according to the lab, you're looking at 2.24% to 3.2% here. All right, so let me add a piece of information to this slide to kind of illustrate how Agrimodis differs from your traditional leaf tissue type analysis of a nitrogen program in this example. So field one was 2.24. We all could probably agree that's low. We need to put nitrogen on there. And 2.45, I think we'd have the same initial reaction probably. But when you look at the plant content of the nitrogen pounds per acre that corn crop had accumulated, they were vastly different for these two that came back low. This one's is 64%, or I'm sorry, 64 pounds per acre. Well, this one has it's over 45 pounds more, 109.2 pounds per acre. And the one that came back sufficient with 3.2% leaf nitrogen percentage contained 82.3. So that's enough to already, if you're comparing, you stare at this long enough and you say, well, I mean, the 3.2 is higher than 2.4 or 2.24, but the 2.45 is higher than the other one, and you start getting confused. And that's why we have the Agrimodis model to where we can set a goal for you. So based on your population, your yield goal, and the stage that you're testing the crop at, well, we're going to say in this particular example, your goal would be 89.4 pounds per acre. So that lends an entirely different layer of interpretation to the Agrimodis nitrogen contents that we got out of these three fields, because field one is low. The tissue was correct, but the content is far behind. I mean, we're at 2/3 of the nitrogen uptake we need at that stage. But field two, even though the leaf percentage was low, we are actually over our nitrogen target by almost 20 pounds an acre. And field three, while the tissue showed sufficient, it's behind my nitrogen accumulation goal by about 7 pounds an acre. So if you're looking at making an in-season nitrogen application, maybe you fertigate nitrogen through a pivot. Well, field one, yeah, you probably need to get some nitrogen out there, or you need to look back at the yield goal you set and what that field history of performance has in good years and bad years to say, maybe I need to adjust that yield goal because I'm at a pretty big gap there. Field two is the opposite. Maybe you need to look at whether that field has outperformed your yield goal in the past in good conditions, and maybe we need to push that yield goal higher to where I'm not necessarily at high end. I just need to adjust my yield goal. Or I am on yield goal and I just need to not put more nitrogen out there because I'm already ahead by 45 pounds or by 20 pounds in that case. Field three, I would have skipped it if I were going by leaf tissue, but it probably needs some nitrogen application because we're still right behind that goal, but we're close. The 250 looks realistic. So the confusion between leaf percentage or leaf ratio, parts per million also, and crop content is across all of the nutrients. So I wanted to give those same three side by sides for the different nutrients as well, just so you get an idea. And we'll do deeper dives into each nutrient as we do future videos. We just want to keep these short. So in phosphorus, you have a difference of 1/100th of a percent. I mean, that's 1/100th of a penny, essentially. And 1/100th of a percent is the difference between 8.5 and 11 pounds an acre of phosphorus. For potassium, a lot of us look at potassium results and we see a low number. We're like, oh, we are in a potassium deficiency. Well, the 2.56% is almost 80 pounds an acre more than the 3% was. So that makes you think we're using the wrong metric here. Look at sulfur at the same 0.33% on the leaf tissue. There's almost a 5 bushel an acre difference in those results there. Calcium, we hear a lot about people trying to get a calcium to a certain level, but 0.49 is higher than both 0.6 and 0.65 in this case. And zinc, similarly, 19 parts per million has more zinc pounds per acre accumulation than 26 parts per million in that leaf tissue. And same with boron. 6 parts per million has more boron content in pounds per acre than 13 parts per million when I compare these samples with each other. So definitely new information that makes you kind of rethink what we thought we knew back a couple years ago. So we won't go through every nutrient. I do want to show you a deep dive on the nitrogen slide where you're dealing with a multitude of samples. All these samples were taken at the same growth stage. And up the left-hand side on your y-axis is the leaf tissue nitrogen percentage of the samples, and each dot represents a different sample. And the lab sufficient tissue range is 2.75 to 3.75, and anything shaded would be coming back sufficient according to the lab, and it would be high if it's above this line. Now, what I want you to be able to see on this is you've got at 3% leaf tissue, you've got a dot here, here, couple here, here. All of those have the same tissue concentrations. Now, if I go right here to this dot at about 3.25, I have another dot at here, here, going straight up that grid, all the way up to like 4.25. Those all have the same nitrogen pounds per acre. Right? So everything on this grid line has 150 pounds an acre of nitrogen. Everything on this grid line going up has 100 pounds an acre of nitrogen. So you have a multitude of leaf tissue nitrogen percentages aligning with each of the nitrogen pounds per acre. Let me add one more piece of information to this graph. At this growth stage, if you have 100 pounds an acre of nitrogen, you're on track for 185 bushel corn if you're on this grid line going up and down here above 100. The other end of this little cluster is 275 bushel corn at 150 pounds an acre of nitrogen. So what I want you to see on this is at 3.75, which is the upper end of sufficiency according to the lab leaf tissue nitrogen percentage criteria, I have dots starting at about 170 bushels going all the way over to about 280 bushels. And we'll ignore this, that's an outlier. So the vast majority of this data, while the leaf tissue is the same for all of these, the nitrogen content and the yield potential is much different. When you run statistical correlation between leaf tissue nitrogen percentage and crop content of nitrogen, it is near zero. It's 0.0033, which is very weak. So that's the misinterpretation of saying we need higher nitrogen percentages. When a higher nitrogen percentage only moves you up on this chart, it does not move you to the right on this chart. To the right is how you increase yield. Going up does not increase yield because you're still at the same nitrogen content. All right, we'll do some more of these. This one ran a little long, about 9 minutes. So we'll do more of these and some of the other nutrients over the next couple of weeks. But thank you for your time.